Yeah. In section 4.7, there's a video explaining how you come up with the equation of a circle. And it discusses what's called the unit circle, which is on your paper right here. The basic equation for a circle with a radius 1, which is on this screen right now, you don't have to write this down, just watch. The equation of this red circle would be x squared plus y squared equals 1. That's the equation of that red circle, radius 1. All right, if you need more of a review on that, go back and watch the video entitled 4.7 Circle Intro. All right, next, to make the circle larger, let's make it green, and let's make the radius 3. Okay, the green circle has a radius 3. No matter which direction you go, whether you go to the right, to the up, to the left, or to the down, the radius is 3, and it's the same distance all the way around. To turn that circle into a larger circle, it would look like this. You take the x divided by 3, and you square it. And you take the y divided by 3, and you square it. And you leave the 1 on the right side. So we have what's called a dilation factor, which you divide by to make it larger. All right, you divide by the number that you want to dilate it by. That dividing actually stretches the graph out. Because if you're going to take your x and divide by 3, you need to put in a larger x. So that's what makes it do that stretching. Okay, you would need to put in a larger x. Think about that. How would, what would make this, let me think about this. Usually up here, you look at this red equation and you say, does this make sense? 0 squared plus 1 squared is 1. Is 0 squared plus 1 squared 1? Yes. That's why 0, 1 is on the red circle. Let's put in the point 1, 0. Is 1 squared plus 0 squared 1? Yes. Okay. The same would go for -1. Is 0, -1 squared? What's -1 squared? Plus 0, 1. So that's why that equation works for that circle with radius 1. The point 1, 0 is on it, 0, 1, -1, 0, and 0, -1. It works going all the way around that circle. Now, if the circle is larger, now what's this point? It's not 1, 0 anymore. What is it? Other way. 3, 0. Is 3, 0 going to produce 1? What's 3/3? What's 1 squared? Plus 0. 1. 1 plus 0 makes 1. So now going around the circle, instead of 1, 0, 0, 1, blah, blah, now it's 3, 0, 0, 3, all the way around. And that's how you make the circle wider and wider. If you wanted the circle to have a radius of 6, you'd put a 6 down here in both spots. Okay? That's how you make the circle larger. What you'll see on the video is me changing the number over here instead of the number under here. And here's why. If you've watched the video, who has? 4 students raised their hand. 4 students, 5, thank you. What did we put over here in this red equation to make the radius 2? We didn't put a 2 over here. Do you remember what it was? A 4. If you wanted to make the radius 3, remember what went over here? 9. If you wanted to make the radius of the circle 4, what's 4 squared? you'd put a 16 over here. Well, in my green example, how come I'm not putting a 9 over there? I'm telling you to put a 3 under here. Here's why. Ready? I'm going to simplify the green equation by doing this. To square a fraction, you can square the top and square the bottom. You know what you're going to get down there? 9. In the next one, square the top, square the bottom. You know what you're going to get down there? 9. You get x squared over 9 plus y squared over 9 equals 1. I can take that 9 over to the other side. Here's how. A little bit of fraction work here. Let me do a little side note, and I'll do the disappearing ink again. Is it true that 1 over 2 plus 1 over 2 is the same as 1 plus 1 over 2? What's 1/2 plus 1/2? 1. What's 1 plus 1 over 2? 1. Right? Did you know that you can do 3/8 plus 1/8 like this? What do you get? 4/8. It works, okay? What I'm saying is, in the green equation, do we have the same denominator? So let's just do x squared plus y squared. It's all over 9. Now, how can you get the 9 to go to the other side? Multiply both sides by 9, and you have the equation that I mentioned on last night's video, x squared plus y squared equals 9, which is a circle with radius, don't say 9, 3. All right? I wanted to show you this way with the number under here, because with a circle, the shape is expanding at the same rate in all directions, horizontally and vertically. With an ellipse, what do you think is going to happen? An ellipse is an oval or an egg. It's going to expand one way more than the other. That's a good way of putting it. What did you say? Different paces. Good. The horizontal stretch might be stronger than the vertical stretch. So how do you think we achieve that under here? The opposite of the same number. Not necessarily the opposite, just different numbers. If you divide the x by 3 and the y by 4, it's going to get stretched vertically more than horizontally. All right? It's going to affect it at a different rate. Before we do that, though, I want to talk about, if you missed it on the previous video, if you haven't watched it yet, how you take a circle and move it. There we go. Where's the red circle compared to the black one? Right and down. Right how far? Down 2. The center is down 2. So the center is at 5, -2. Here's how you would write that equation. Instead of x squared plus y squared equaling 1, we have to put in some translations. To make it go right 5, you do -5 in there. To make it go down 2, you put a +2 in there. With circles, it's kind of the opposite of what we know in the past for up and down. And here's why. Another quick side note for those of you who are still with me. How would you take the square root of x and move it down 2? Like that? Is that the square root of x down 2? What would that 2's sign be if it was over here with y? right? If the up and down shifter is with Y, it's plus for down and minus for up. So with a circle, that's what we have to follow. The up and down shifter is in there with the Y. So plus is for down and minus is for up. Those are the basics for circles. If you missed the first video, here's another one for you. I'm going to stop and do the ellipse in a second